Right, so the next topic is power. Section 14-9 is power and efficiency. So power is so before that we've looked at work, energy, but sometimes just knowing how much work needs to be done is not enough, because sometimes that work needs to be done in a certain amount of time. That means that much energy needs to be expended in a certain amount of time, and that's called power, right? For example, if you're pulling something out of like let's say something is stuck in a ditch, you have to pull. So you must have heard people say you need more power. That means you need the energy, but you need that energy as a burst of energy, right? So anytime we're talking about power, then it is the rate at which work is done, or the rate excuse me, or the rate at which energy is expended. So from that we can get this formula for power. Power is work divided by time. Now in the past you have seen work, energy, and different forms of energy. They're equivalent in this sense. We know we know that work is force times distance, right, divided by time. Now what I can do is I can actually do something like this, right? So I can say force, power is force times distance over time is velocity, right? So that's also a definition of power. Okay, the units of power, as you can imagine, work is in joules per time in seconds, and joules per second has a special name, that is watt. Okay, all right. So just the same way as joules is a short name or another name for Newton meter. Okay, so same way, joule per second is watt. Okay, so we can also, this is also the same as Newton meter per second. Okay, Newton meter per second. And you can see that this kind of looks like this, Newton meter per second, right? And in the English units, you have horsepower or foot-pound per second, right? Newton meter is the same as foot-pound or pound-foot per second. That's the English unit. Now when things are rotating, this is linear, right? So this is linear, but when things are rotating, they're in a rotational motion. You can say the rotational power is torque times angular velocity, right? So that's Newton meter, that's for torque, right, times radians per second. Now radians is just a non-dimensional quantity, right? It's like angle, so its dimensional units are just 1. So basically this reduces to Newton meter per second, which of course is the same as the power we've seen here. Okay, Newton meter per second. Okay, so in this sense it really doesn't matter if the motion that is being produced is linear motion or if it is rotational motion. The power is the same and the units of power are the same. Okay, coming to efficiency. Efficiency is how much output you're getting for every watt of power you're putting in. Okay, so power output divided by power input. Of course, times 100 gives you the percentage efficiency. Okay? So simple set of formulas. Now with these formulas, let's solve a simple problem. 14-89 in your book. What thrust is being provided by a propeller of a boat if the propeller uses 22 horsepower to produce a boat speed of 16 miles per hour? Okay, so we need to find thrust. Okay, the power is given as 22 horsepower. Okay, and the velocity, speed of the boat is 16 miles per hour. Okay. So velocity is 16 miles per hour. Right. So we start by converting these units to, now the formula that combines power, velocity, and force is, power is thrust or force times velocity. Okay. Now 22, the power is given in horsepower. Okay, we need to convert it to foot-pounds per second. So 1 horsepower is 550 foot-pounds per second. So horsepower, so each horsepower, 1 horsepower is 550 foot-pound per second. Okay, it's equal to the thrust. We need to find that out. Velocity is 16 miles per hour. Convert 16 miles per hour times 1 mile is 5280 feet times 1 hour is 3600 seconds. So when you do all of that, let's see, you get 23.5 feet per second. Okay, so 23.5 feet per second. Okay, so here horsepower cancels out, feet second cancels out. So so F equals 22 times 550 divided by 23.5. That's equal to about 515 pounds of thrust. Okay, let's look at another question. This is problem number 1491 in your book. Let me read it. What is the power output of a motor that provides a torque of 4 kilonewton meter while running at 1600 RPM? Okay, so the torque 4000 Newton meter, speed is 1600 RPM. Of course, you know we cannot use RPM directly like this. We need to convert it to radians per second. So let's convert it to radians per second. So 2 pi over 60, that gives us about 167.6 radians per second. Okay, so simple. So power is equal to torque times omega. So torque is 4000 times 167.6. What do we get? 167.6 times 4,000, 670,400. 670,400. So you get so many joules per second, or let's just write watts. Okay, or you can divide by 1000, and generally when you have a large number like that, you convert it to kilowatts. You can say 670.4 kW. Okay.